I'd like to, show of hands, I know you're hearing very bold statements from John Petty so far, from myself. Show of hands, I know we talked that it's ambitious. Does it still sound a bit like fantasy? Does it sound realistic or? I didn't hear you. Yes, question for you. Did it sound like fantasy, what we've described so far? Or does it sound doable? Show of hands, how many think it's doable?
No,
okay, good.
Of course.
Well, we'll take it a step further. We got an engineer with us, senior principal engineer for Intel Corporation, Arvind Kumar. He's going to take a step here to make it even more real for you. Okay, let's give him a round of applause.
Hey, thank you, Neil, for inviting me here. And thanks, John, for great insights there. So I work at Intel, and I'm also acting chair of one of the three work group. But Chris Kelly, who returns from sabbatical next week, is the real chair, but he's my manager. So you know who will have to do the real work anyway. So what I'll talk about is give my view of the client-to-cloud revolution in the context of the compute, data, and code, and how that gets distributed across the different components from the cloud to the client and everywhere in the middle. So let's look at this client-to-cloud, the dash here. Let's talk about this dash. Does it mean that the compute and the data and the code, everything moves to the cloud? Well, there is value, there is lots of benefit when you get to use the power of the cloud. You get the collaboration and sharing. That's the reasons why the software as the services providers and solution providers are moving to providing the services on the cloud. Gets to collaboration sharing. They get to have the right monetization model with the subscription that they can get for their services. Allows them to have the services that go across the devices. So you have the cloud-based service, and you can use that any device you want. They can scale their service, easier for deployment, manageability, and get the better security for the cloud with the consolidation of the resources and the manageable resources. So definitely, the cloud brings huge benefits, and that's why we're seeing the revolution as the cloud is at the center of it. But there is a lot of things that needs to go the other way. And to provide the best experience when it comes to the responsiveness and interactivity. When you are interacting with this cloud service, your application, the thing that is closest to you, the devices, your computers and your phones, that's where you do the interaction. So to get to the responsiveness, you really need to process that locally. Offline use, you get intermittent connectivity, and suddenly you don't have a capability if you are all going to the cloud. So the reason to process locally, there was an example right today when I was giving the file to Neil, and he said, well, I don't have my connectivity. Can I use just the floppy? Well, if you had a function right there, that would work very well. Data control privacy. Do you want to send from this plethora of sensors in your home, your camera is connected to the internet, sending all your video and streams or the audio streams to the cloud? No. You want to do the filtering. You want to control what the data you send to the cloud. And there's a privacy aspects of it. There's a cost of network, even if you could send all the data to the cloud and process. There's a cost of the network that comes into play. And you want to interact with the best form factor, the devices, your gestures, and interacting with the devices, the speech with the gestures, with the best input methods, with dual screens, double screen, foldable screens, and all sorts of interesting ways that you want to interact with your content and with your services. So my view is that it is actually both. So the client to cloud and the cloud to client and everything in the middle. Best is to use the experience of the client and the power of the cloud to deliver the best experience to the user. Now, let me play a devil's advocate. Let's say if your network is going to be super fast and you have lots of network bandwidth, would all of these benefits on the left sort of disappear? The responsiveness, low latency, and some of those vectors. Well, let's look at that. Yes, agreed, networks are getting faster. We had less than a megabit per second speed with 2G, and now it's going to gigabits per second. Now, you can still argue whether the realistic way with the 5G is going to be, will go to 10 gigabits per second or not, but that's not the important point. The thing is orders of magnitude better network. Sure. And it will continue to increase. Now, so we had this small little road with single lane congested traffic with in the past. We're building better network, and you have a nice 6-lane highway here. Now, the problem is that the data is ever increasing too. Now, what used to be the pictures in kilobytes with the single-digit megapixel now to 45 megapixel cameras that you get. And if you took a look at the raw image from some of these, the cameras is 50 to 100 megabytes images, right? Videos from standard definition to high definition, ultra high definition, 4K, 8K, lots of data. Display resolutions. Used to be VGA, XGA, HD, again full HD, 4K, 8K. And the sheer number of the devices, 50 billion devices and trillions of sensors that can produce the data and send it to the cloud. But do you really want to do that? Do you really want to do that? You build that 6-lane highway, and pretty soon, that's all in traffic jam. So, even if you had the network bandwidth, the data is going to be, I mean, it's already there. I mean, if you look at what 5G will get you, if you look at all the data that even exists today, the bandwidth is not sufficient. So look at some other aspect of it. Bandwidth I talked about, but it's not just the bandwidth, right? What I draw here is looking at different axes here. And where we are today, what's realistic in next 3 years, maybe 5-7 years. And we can argue whether we will get to 10 to 100 gigabits per second speed at some point. But I put that a hypothetical ideal, that it's not likely to happen, but let's assume if we did, but there are other, and you could actually send all of your 40 megapixel images to the cloud in an instant with 100 gigabits per second. Would that matter? Would you say that, hey, everything we can do it on the cloud? There's a latency. So not just the bandwidth. Now, again, with the 5G URLLC, we are targeting very small latency from the network perspective, but then it comes to end-to-end latency. It is from the time you click on something, your data goes to the cloud, gets processed, comes back up when you see the action. So it's a trigger to action. If you're looking at playing a game, this is essentially when you do something and when you see the effect of it on the display. And that's not going to get to less than 1 millisecond, which you really need and be really close to where the expectations of the experience continue to change. The network uses cost. So even if you could send this, nobody is going to provide that infrastructure for free. There's a reason that telcos are providing that infrastructure, and there's a cost to that. That cost will continue to reduce, but if it was free, then we could kind of look at that. We can send all the data, but that's never going to happen. There's availability of connection. Yes, the connectivity will be great in certain places, but like this morning in the hotel connectivity, or you're on the airplane, you're not connected sometime, you're offline a number of times. So it's not, you will not get the always on connectivity. But if we had that, then there is a cost of the compute. We're already starting to see that processing this lots of data on the cloud. The CSPs and the service provider are starting to run into this thing. Hey, in order to get my EC2 servers or EC2 instances or the Amazon or Azure instances, I have to pay. And if from the service provider, this is a huge cost, and CSPs are wrestling with that. Storage, that's the storage cost again. When you have this trillions of sensors and the billions of devices sending the data, and you put all the data on the cloud, this is going to have the cost impact. And users would want to only do that if it gets into very low cost or even free. But even if all of those are true, data privacy will remain the issue. That I still don't want to send all the data, even if I could, because I care about the data from the privacy perspective. I don't want to send this unfiltered data. I would really want to do some filtering before I do that. So where we end up, we look at, there's the cloud and the devices things, and the edge and the core network is the things in the middle. We have to do the compute everywhere where the data can be processed, as opposed to sending all of the data. That you can see sort of in this visual here, number of devices, there's a lot of data will go to the edge, and some of that, actually a lot of data will get processed in the client and the device itself. And parts of the edge, there's the edge level processing that happens, and all the way, then very filtered data actually should go to the cloud. So the point here is, if you could send all the data to the cloud, you still would not want to do it, because the question here is it efficient to send gigabytes of data from the device to the cloud, or have megabytes of code or function, bring it down from the cloud to the device and process it there? Since it is a two-way street, both sides you can transfer the code as well as the data. So ideally, you would compute where the data source is. Bring the compute functions, which are definitely smaller in nature than the data that is being produced, and the compute where the source of the data is. So if the sensors and the devices are producing the data, then that's where the compute should really happen. So keeping those highways congestion free. And the key to that is doing the compute where the data is. So getting into real, what does it really mean? What it means is expanding what we have, work that we have as an industry have started on the cloud with the functions and the microservices being orchestrated from the cloud to the edge to multiple different data centers. The smaller functions get distributed. Today, some of the cloud providers like Google Anthos is going multi-cloud, and to the on-prem edges, to the premises where those functions can be deployed. We want to take it all the way further to the devices in the client so that those functions that are write once, run anywhere, packaged in containers, can be deployed as a part of the service from cloud to the edge to the client all the way across, wherever it makes sense for that particular uses. So important, write once and run everywhere, the packaged code in a standard containers. And in order to have the scale that we really want for this compute distribution to really work, as Neil was pointing out, I always say that standard is the way to get that scalability. So open container initiative, Docker packages, extending the orchestration frameworks like Kubernetes and such from beyond the data center to the edge to all the way to the devices and to the client. And treat the client as sort of a rich, secure, and intelligent node in the cloud. So everything is, so you have cloud, and there are different nodes. The devices and sensors become a node, and depending on the uses, you're essentially deploying the functions that make sense. So I'll give a few examples where the good combination of cloud and client kind of brings the better user experience when it comes to the latency, interactivity offline, or the data bandwidth and the privacy factors. So cloud gaming, immersive content, Neil mentioned Stadia and xCloud and all that are starting to provide the capabilities, but the experience will just get much better. If you have certain functions from that, things like a rendering or local interaction, local loopback, the controller to action, those functions be delivered to the client as you are playing the game and you're using the richer capabilities of the client. You get much better experience. Natural language understanding. You can go to the Alexa, Cortana, Google Home, and if there's no connectivity, you can't ask it any question, although you may have a lot of local intelligence in the premise that you are in with the sensors and the devices and your client computers to be able to do that offline and in the low latency interactive fashion. You get a lot of benefits by doing that processing locally. I mentioned the privacy and angle where you really don't want to send all the data back to the cloud. You may be, the good example says in a video collaboration, want to get rid of all the background things and you want to do the local processing before you send the data. Or number of different sources that are feeding the data into your computer. You want to do the personal broadcasting, and doing that function and processing locally will just increase the experience and build the better experience. So I'll leave here with a number of examples in here. And the summary, I will just say that the really benefit is between the cloud client and the cloud, and this dash that we are looking at, it is really a two-way communication as we look at the compute, the data, and the code. And we need to really look at how we move the code closer to the data. With that, I'll pause here, and of course, we'll have questions in the panel discussion, I suppose. Thank you.